now in this section we're looking at set complements, and complements are the opposite, if you will, of something. So it says if A is a subset of the universal set U, then the complement of A is the set of elements of U that are not in elements A. So basically, if A is all the evens, then A prime would be everything else, the odds. So it's the opposite, the complement of what you're looking at here. So let's take a look. So here's another way of saying it. It's the things that are, if A is the set that is in U, then these are all the ones that are opposite of that. So not A. Sorry, that sounded a little confusing. Let's take a look at better numbers here. So we've got set U. This is the universal set. Okay, is from 1 to 10. In other words, our big set is 1 to 10. A is only the numbers 1, 3, 5, 7, 9, all the odds. So our complement of A is the opposite of the odds, which are the ones left over, 2, 4, 6, 8, and 10. So it's the set of elements that are in the universal set, 1 through 10, and not in this guy right here. So all the ones that are left over are 2, 4, 6, 8, 10. Okay. So let's talk about it from a different perspective. I've got U, the universal set, is a set of people living in the United States. F is a set of people who have pages on Facebook. So obviously not everyone in the U.S. has a page on Facebook. Good amount of them, but not everybody. So U prime is going to be, or sorry, not U prime, F prime. F is our set. F prime is the set of people living in the United States who do not have pages on Facebook. It's just the opposite of whatever your given set is. So this one is do not. And then let's say our universal set is the set of cards, standard 52 card deck. F is the set of face cards. Okay, so our F prime would be the set of non-face cards, be everything else. All right, so let's take a look at doing some set differences. So the differences of sets B and A are going to be doing some subtraction of these two sets, and that's saying B minus A, the way that this is written is, I had this whole set here, and I cut out everything that A overlaps with. So this part is cut off, and I'm left with just this portion of B here. Okay, so we're going to be doing some subtraction. So let's take a look. So I've got, if this is set B, if you will, and I'm going to take away this set A. So I got 3, 6, 9, and 12. So this is saying subtract all of the set that X, such that X is an odd integer. In other words, take away all the odd integers out of set B, and so B minus A is going to leave us with 6 and 12. So you're just subtracting out whatever the second set is telling you. So let's take a look at another one. We've got the physical exercises of earlier, that big long chart list on the previous video. And here we're going to take and subtract E minus L, and then we're going to do L minus E. So here, oops, thought I had it popping up for me, that's right. So E minus L is going to take YO away from here, but it's not in there. We're going to take EL away from here. We're going to take TE away from here. So the result is going to be the set RT, comma BI, which, if you notice, it's the complement of the union. So let me actually write that, or sorry, the intersection. The complement of the intersection of E and L. If we did the complement of that, if we go back to our answer that we had of the intersection of those two, it's actually the complement of those. But anyway, so RT and BI. And then if we do L minus E, you're going to get the same result. We're just taking these ones away from these. And we would end up, sorry, I said it's the same result, and that's not true. We're subtracting the same quantity, the same parts of the set, but our answer is going to be different. So here, let me erase those so we can actually look at it. And so when I do L minus E, our result is going to be taking RT away, it's not in there. Taking BI away, it's not in there. EL is, so we're going to cross that off, and TE is, so we're going to cross that off. The only one left over is YO. So our resulting set is going to be YO. Okay? So it does matter which direction you have your subtraction set up. And now here we've got more arithmetic operations, and it does matter which order we do these things. And the set notation specifies the order in which we perform the set operation. So what we're wanting to do is we've got our universal set is the numbers 1 through 10. And we're saying E is the set that is even numbers. B is the set of 1, 3, 4, 8, or 5 and 8. A is the set 1, 2, 4, 7, and 8. And so we have to do some work. It says find A union B, and then the complement of that. Intersected with E complement union A. There's a lot going on here. In fact, we're going to work it out step by step here. So notice I got some numbers hanging over here. That's because we're going to be breaking this down step by step. So first thing is to notice is that we have to do the union of A and B first before we can do its complement. Then we're going to need to come over here on the right side and do the complement of E before we can find the union of the complement of E with A. And then we're going to have to find the intersection last after finding those two results, finding the complement of this guy and then finding the union here. And then our very last step is to find the actual intersection. So let's do it step by step. So first thing we're going to do is, like I said, find the union of A and B, and that is just taking all these numbers in the list and writing them out once, and that's going to look like this: 1, 2, 3, 4, 5, 6, 7, 8. So this is the inside here. Now we're going to eventually have to find the complement of that. So let's do that. We've got our set here, and so the complement is everything else in the universal set 1 through 10. That is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the union here. It's going to be 6, 9, and 10. The element's not in the union of A and B. So then that was step 2 up here. Now we're going to come over and do the 3, which is to find E prime, the complement of E. And so I said prime because that note or that mark right there is often called prime. Anyway, the complement of E is everything that's not E, which would be all the odds. So 1, 3, 5, 7, 9. In other words, the ones that aren't even. So we find then the union of the odds and set A. So that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is going to be the union of sets A and all the odds. So in other words, we had 1, 2, 4, 7, 8 here, and then we just add in the odds from this set. So then our job, this is basically, let me erase what I have here. This is all this stuff. And then our 6, 9, and 8 was all of this. Our job is then to take the intersection of these two sets that I have circled up here, which is written out right here. And so our intersection is which ones overlap, which ones are in both actual sets. And notice 6 is not in both sets, 9 is in both sets, 10 is not. So 9 is the only thing that is going to be our result that is in both steps 2 and 4. So our final answer of all that work was 9. So then we've got here order of calculating unions and complements. So here we've got a universal set again, and we've got set A and set B, 1, 3, 5, 1, 2, 3. So here, just working out some order. If you follow the last problem, you're going to be able to follow this one probably just fine. But notice here there's a difference. This is A union B, and then do the complement. This one is saying do the complement of A, do the complement of B, and then do the union of the two. So let's see how this unfolds. So for A, we want to find the union of A and B first. So we come over here and do the union of A and B, and then we will do the complement of that second. So the union of A and B is 1, 2, 3, and 5. That's all the numbers in the set. And then the complement of that is 4. So in other words, the only number over here that we haven't listed at this step is the 4. So that's why our answer is 4. Then let's do the second one. This one says do the complement of A, then do the complement of B, and then see the union. So the complement of A, then the complement of B is going to be 2, 4, and 4, 5. So the complement of A is here, the complement of B is here. The union of those two is 2, 4, 5. Notice how the answer is much different than the one above it. And this again goes back to, very often I have students think that they can distribute an exponent, and it doesn't work out here, even though it's not really an exponent, it's a complement. It does not work to be the same. Completely different answers, 4 and 2, 4, 5. Very big difference.